Hello everyone, welcome to OR2. This is the first chapter of OR2, and the title of the first chapter of OR2 is the network model. So in this video, I will give you an introduction on the network models. In our real life, there have been so many applications of network models. Now, see this example. Number one, so the design of the gas piping system, and we want to have the construction costs of the pipes of the piping system to be minimum. That's one of the application of the network models. Number two, we want to find the shortest route between two cities. Okay, that's another application of network models. Number three, we want to determine the maximum capacity of a belt conveyor system connecting a coal mining and a let's say a factory. Okay, and number four, we want to determine the scale of a what we want to determine the scale of a piping system in which inside that piping system we transport oil, for example, and the transportation is between the oil rig or oil mining to the oil distribution center. Okay, so those are the four applications of the network models. Okay, so we have four example real life problem here. Okay, so we can solve problem number one by using the first model of the network models. And the first model, so you see the problem number one here, we can solve it by using what we call as the minimum spanning tree model. Problem number two here, the shortest route, we can solve it by using the shortest route problem, by using the shortest route model. And problem number three, in which we want to determine the maximum capacity, we can solve that problem by using what we call as the maximum flow model. And the last problem, which is we want to determine the schedule, we can solve it by using the minimum capacity model, or network minimum capacity model. So those are the four types of network model that we will discuss in this chapter. So we will discuss the first model that we're gonna discuss is the minimum spanning tree model. Number two, the shortest route model. Number three, the maximum flow model. And number four, the network minimum capacity model. And sorry, there is a mistake in the name of model number four. It should not be network minimum capacity model, but it should be it should be network model with minimum cost, and the network has its capacity. So that the correct name for the model number four. So I repeat that there will be four models that we will discuss in chapter one, or in network models. Number one is the minimum spanning tree model. Number two, the shortest route model. And number three, the maximum flow model. And number four, we will determine the minimum cost for a network, and that network will have its capacity. Now, all those four models basically all the above models, they are linear programming problems. So since they are linear programming problem, we can solve them using simplex method. Okay, so because they are linear programming problem, we can solve them using simplex method, but it is not recommended. Okay, why it is not recommended? Because there are special algorithm designed to solve the above four models. Okay, so those four problems are linear programming problems. Because they are linear programming problems, we can solve them using simplex method, but it is not recommended to solve the problems using the simplex method. There are special algorithms designed to solve the above four models. So there are special algorithms for the minimum spanning tree model. There is special algorithm to solve a minimum spanning tree model. There is a special algorithm for the shortest route model. There is a special algorithm for the maximum flow model, and there is a special algorithm to determine the lowest cost for the lowest cost for a network, and that network has its own capacity. So this is the basic introduction to the network models. Now let's continue on the definition of a network. Okay. Now, a network consists of node connected by arc or branch. So a network consists of nodes connected by arcs or branches. Okay. I will give you an example of a network. So we will draw a network. So in order to present a network, we need to draw that network. So a network consists of node. So let's say that we have 1, 2, 3, 4, and 5. So those are the nodes. So the nodes is represented by a circle. So we will put number on the node. This is node number 1. This is node number 2. This is node number 3. This is node number 3, and this one is this should be node number 4, and this one is node number 5. Okay, and the nodes are connected by arc or branch. So we will represent the branch by using arrow. Okay. So this is an example of a network. So it consists this network consists of 5 nodes, and all nodes are connected by arc. So in order to write the network, or to the notation of a network, so we will use G, so capital G, as a network. So we will label this network as the network G. Okay, since a network consists of node and arc. So capital G consists of N, which is node, and A and arc. Okay. So G consists of nodes and arcs. So we write it as G equal, in parentheses, capital N, comma, A. For our example, okay, before I go to the example, so N is for the nodes, and A is for the arcs. Okay. So for the example here, the network over here, so we have N consists of 1, 2, 3, 4, 5. So since we have 5 nodes, so N equal, in parentheses, 1, 2, 3, 4, 5. Okay. And the arcs, or the A, consists of what? It consists of the first arc connecting node 1 and node 2. So it is 1, 2. So in parentheses 1, 2 means and the arc that connecting connects node number 1 and node number 2. And we have 1, 3, which is the arc connecting the node number 1 and number 3. And then 2, 3, 2, 4, 2, 5, 3, 4, 3, 5, and the last one is the node connecting the arc connecting node number 4 and node number 5. So this is how we label or we write the network, or this is the notation that we use in order to write a network. So it is important also to remember that for the arc here, so we have arc over here, arc. So the arc usually in the problem, so the arcs of a network usually have its maximum capacity. So for example, if the arc is the pipes, so that pipes will have the capacity of what? For example, oil flowing inside that pipes every hour, for example. I think this is enough for the introduction for chapter 1, the network models, and we will continue with chapter 1 in the next meeting. And thank you very much.